My guest today is Professor John Sullins, who's Professor of Philosophy at Sonoma State University and the Director of Programming for the Center for Ethics, Law, and Society. He specializes in philosophy of technology, philosophical issues of artificial intelligence and robotics, cognitive science, engineering ethics, and computer ethics. Welcome, John.
Thanks, Gill. Looking forward to talking to you.
Yeah, so thanks for doing this. So we want to talk about your book, Great Philosophical Objections to Artificial Intelligence. But I want to start with sort of the prelude to the book, I guess. You had a paper out in 2021, The AI Wars, 1950 to 2000, and Their Consequences.
Right.
You say philosophy and AI have had a difficult relationship from the beginning. The classic period from 1950 to 2000 saw four major conflicts. First, about the logical coherence of AI as an endeavor, and then about architecture, semantics, and the frame problem. And since 2000, these early debates have been largely replaced by arguments about consciousness and ethics, arguments that now involve neuroscientists, lawyers, and economists, as well as AI scientists and philosophers. You say we trace these developments and speculate about the future. This is a topic of great interest to me, John. Just to make sure that the audience understands my bias, I was part of one of those waves in the 1980s. I did quite a bit of work in what was then called expert systems. First in engineering, using IBM 370 with punch cards in Fortran.
Awesome.
show my age here a little bit. And then I got to Northwestern. I got the first IBM PC and Pascal, and we put together an expert system for engineering education of graduate students in 1985. This was early attempts of what we now generally call artificial intelligence, but these were called expert systems. They were rules-based, and they were really sort of an attempt to use the computers, I would say, more efficiently to decision-making and those types of things. So you talk about four major conflicts or four major waves here. Could you talk a bit about the history starting all the way from 1950?
1950. So yeah. So what we're trying to argue in that paper is taking a look at AI not only from an engineering perspective, but also from philosophical perspective, because there's a number of really interesting philosophical claims that AI can either help us with or challenge within philosophy. So, for instance, human specialness, is the human mind something that is unique, or is it something that can be easily modeled and implemented on a machine? Is computation the correct ground level, sort of foundational level understanding for how information is transferred even in biological creatures? So in the 50s, of course, we have, right after World War II, we have a very strong claim in this direction made by Alan Turing. And Alan Turing, in his seminal paper, tells us that computation can be defined, and can be defined broadly, and can be defined in such a way that it's not it doesn't refer only to a particular machine. It can be defined as a logical process that can be implemented on any sort of machine. And then he develops his concept of the Turing machine, which is really a logical construct, and it's not really an actual machine that one could engineer, but it is a way for him to describe how exactly computation works. Turns out to be relatively simple, but it turns out that you can do lots of things with the Turing machine, and most importantly, a Turing machine doesn't necessarily have to be purpose built. It can reprogram itself. So you can develop a Turing machine that has the ability to create more Turing machines. So therefore it should be able to, at least theoretically, solve any problem that that it gets confronted with, given enough time and enough computational power and all of that. Yeah, you always have to remember Turing machines exist in a logical world where they're not really worried about energy and how the machine is powered, and it has infinite amount of time and an infinite amount of space to work in. So that's a pretty those are pretty special circumstances. But given those, then this machine in a pretty simple way, with just inputs and outputs and a memory tape that it can change the entries on, you can now develop basically any sort of it basically is the definition of what computation is. So that's pretty clever, and he uses it to do some work in mathematics, and then he writes this paper that suggests that there is nothing more to intelligence than computation. So if a Turing machine can implement intelligence, and electronic computers can implement Turing machines, then electronic computers should be able to be intelligent. And he says things in that paper like, within 50 years, no one will contradict me. Right now, right after World War II, yes, I expect everyone to contradict me, but in 50 years' time, and no one's going to contradict me. Everyone's going to agree that computers are intelligent. So we're well beyond 50 years from the time that paper was written, and so we can now sort of look back and say, was he right? Was he prescient in this way? Do we consider computers to be intelligent? And so that's like the first war, like the first conflict with philosophy is mathematicians and computer scientists. Well, there weren't really computer scientists back then. They were all mathematicians, but they were turning into computer scientists, and they stepped into this world that philosophers thought that they had full control of, which was philosophers were the people that talked about human intelligence. Then they got a big chunk of it taken away by psychologists, and now they're going to have another, like the rest of it, taken away by computer scientists. So they fought back, and that was the first sort of conflict was, if you look at philosophers like Lucas, and they argued that there were strict logical limits to what could be considered computation, and those, for instance, one particular strict computational limit would have been the Gödel's theorem and Gödel's limitations on understanding where the limits of proof making could go, right? So he has this incompleteness theorem, and in the incompleteness theorem, he proves that within mathematics you can have a theory that is well, you're never going to have a theory that gives you everything that you want, that gives you all that allows you to deduce all truth from the theory, or that allows you to have an end, sort of an end to the process. So this then being a limit that was placed, that one could argue was a limit to computational theory and any pragmatic or practical implementation of computational theory, you should run into this problem.
So John, for my own understanding, so the conflict here is mathematicians and computer scientists look at the problem as extensible and complete, or completely solvable, let's say.
Completely solvable, right?
And philosophers don't agree with that.
Yeah, this branch, especially this first branch of philosophers that were initially confronted with this problem, were mostly critics, right?
And so that's sort of the first conflict, and it's sort of a natural conflict in the sense that most scientists are, I would argue, generally overconfident
Right.
about solving problems. And philosophers may have sort of a broader view as to the constraints that might face the brain in the long run.
Right.
And so then we come into, is it the 70s then, the sort of the next wave of this?
Yeah. Well, we should, before we get there, we should, because there's probably some listeners who aren't familiar with this territory, and we should talk a little bit about the very famous Turing Test, because that is very easy for people to understand. It doesn't take a lot of technical skill to understand this particular argument. So this was an argument that Turing made for the general public. And in this argument, he proposed that we set up that computers will have to be, even the general public will have to agree that computers have reached the intelligence of humans once they're able to pass this test. So how does this test work? We take the computer, we put it in one room, we put a person in another room, and then the examiner, another human, is in a third room, and they get to ask questions via, back then it would have been teletype, right? So it would have just been a typewriter typing on the electronic typewriter, typing in front of them. And so you would type your questions in, wait a few seconds or minutes, and the answers would come out. And so they would just be labeled room A, room B. So you could ask any question, right? There's nothing is off limits. So you could ask any question you want, and then after a period of time, the examiner makes a distinction. I think the computer is in room A or in room B. And Turing says, once we get to the point where you can't get this right, no better than chance, then we have shown that a computer is intelligent. So in today's terms, it would be like imagine texting some users in a social networking app of some sort, and you never really meet these people, right? Maybe some of them are AI chatbots, and if these AI chatbots convinced you so well that you never really thought they were an AI chatbot, you always assumed they were just another one of your mini online friends, then basically we have shown that the Turing test has been passed at that point as well. So that would be a modern version of the old 1950s proposed test. They do this test all the time. Interestingly enough, arguably some programs can pass it in limited categories. Like if we say we're only going to talk about Shakespeare plays, right, or whatever topic that they want to put the test in. Some programs do pass that test, but as far as I know, and I would, this would be big news if it was possible. No program has passed that general Turing test. For instance, Gill, you could have contacted me, and then instead of me actually showing up, I run an AI program that simulates video and the chat and the whole thing, and we do this whole interview, right? And you never know that it was an AI that was doing it. That's what I mean by passing the Turing test.
Yeah, I'm just remembering things, John. So I was very enamored by, I don't know if you looked into this, programming languages like Prolog and Lisp.
Oh yeah,
in the
right.
80s.
Mm-hmm.
And Prolog was a major advancement in terms of programming.
Yeah.
Because you could actually fool people
Right.
in this Turing Test context, right?
Yeah.
But it didn't go anywhere.
hmm
I mean, you could fool people, but fooling people cannot be an
Right.
objective of program.
Yeah, that's right. Prolog and Lisp, I think, I think it's safe to say that a lot of what was pushing those languages was thoughts around this Turing test, right? How do we actually make this thing happen that Turing said that we should be able to do? And both of those languages were explicit attempts to try to codify logic and language into computer programs. They're beautiful programs, but you're right, they weren't the end all answer, because they turned out to be limited in their applications to this specific kind of problem. So that tells us maybe two things. One being that maybe this was the wrong problem, right? Which is one of the conclusions that we draw in our paper and in our book as well, is that that maybe this was a red herring, right? That sent AI down a wild goose chase for quite some time, or Turing's just wrong, right? And this can't be achieved.
Yeah, I mean, there's an engineering constraint. One could argue, conceptually, we don't have the right tools to make AI. So we have complex programming languages. The Japanese, I believe, in the late 80s were so enamored by Prolog, they were going to create an operating system based on
Prolog.
The languages we have today, C++ and Python and things like that, they are fairly highly structured languages,
right?
Probably incorrect tools for artificial intelligence.
Right.
So it might be that the concept is right, but we just don't have the tools to make it.
Yeah, I think that's really an important point. As you say, there were these programming languages that were geared towards this problem, and then we moved to other programming languages that are not geared towards this problem. They're geared towards databases and stuff like that. So so they work on those problems a lot better, but they start to really fall apart on this particular problem. So yeah, I think you're absolutely right. Is that the tools matter towards what problem you're looking at. One programming language is not identical to the next, and they all have various strengths and weaknesses, and that I think is a really interesting. It's an interesting problem for AI, because of course there's AI like we have today. What I like to call AI applications, just AI directed at very thin specific problems, does a great job on that. But then there's AGI, right? Artificial General Intelligence, which is a kind of a program that can generally function across multiple domains, all kinds of domains, and that we don't have, and it may be because we also don't have a generalizable programming language, right? A language that is good at all potential problems.
Appears to be a bit of a pipe dream, John. I know that Google paid $500 million for Deep Mind.
Right.
The problem with AI today, I just want to come back to your book, but the problem with AI today, I think, is so much hype in it. It's very difficult to understand reality from hype, right? I mean, there's so much noise around it. And so just going back to historical context again. So I know there was a Dartmouth conference, right?
Yes.
When was that? In the 60s?
So yes, the Dartmouth conference was where the term AI was coined, and in the very first place. And at this conference, you had some of the early luminaries from Stanford and Carnegie Mellon and Dartmouth and MIT, and a bunch of big names in the world of computer science, and they got together and sort of set the tone moving forward. So late 60s, 70s, 80s. What was AI, and what were the problems that it should try to solve? So that they coined the term artificial intelligence. I from reading, the people who attended that conference, they tend to suggest that maybe that wasn't the greatest name that could have been used, because of the word artificial, right, makes it sound like fake, right, and so that has always like just in the very name of the discipline itself has given people like philosophers unlimited ammunition, right? So so that was probably a mistake, right? They probably could have came up with a better name, but we're stuck with it now. And then they set the project, right? The research project. So the research project was going to look for theorem proving machines, chess playing machines, and these kind of chatbot applications. Also tacked onto the side would be problems that you need in robotics, vision, mobility, and proprioception, right? Where I am in a physical environment. So so those became kind of the big problems that then all the graduate students lined up, right, to fill those slots, and then we have the next few decades of AI research.
And so the 80s, as I mentioned, I was one of the people who fell in love with expert systems and then had to abandon it, so to
Right.
speak.
Yeah.
And so there was a period, right, that people
Mhm.
thought, yeah, I mean, so we can, put together rules.
Mhm.
Yeah, I don't know if expert systems was the right name either. I mean, this was
Right.
really using computers in automation,
Right.
I would say,
Yes, exactly.
make humans more efficient, right?
Yep. Yeah, this is another excellent example of where the name matters, right? So when we choose the name expert systems, then and that feeds back into the that it's always going to be in the back of everybody's mind, this kind of science fiction idea of what AI is, right? So we're thinking un un unfailing machines, right? Machines that are going to be so good at what you say they're good at, they're never going to make mistakes. They're going to always do and predict and suggest the right outcomes. So so that was a problem, because, as you well know, I entered this world a little bit after that, so early 90s, just as expert systems, like there were still grants for expert systems. Uh, Doug Lynat's Psych project was still going, right, which was going to be the ultimate expert system of expert systems, and so we were looking at this, but in my program we were like, this was late in the game, so there were clear clear problems with this way of thinking, because rules are not flexible, and even the best list of rules will work some of the time, but then when it fails spectacularly.
It's very rigid.
Yes, very rigid, very fragile, and so this was a problem at the time, right? The new challenger was really an old challenger, which was machine learning, and machine learning had been around since prior to the 80s, so it was way back in the 60s, right, where the first modeled neural networks, and that what's really interesting, what we track in the paper and in the book, is this really was a war, right? The between the machine learning people and the rules-based community, and there were careers lost, right? Rosenblatt, who invented these things, like, committed suicide after Minsky destroyed him in a paper, right? But when you go back now and you look at that paper, you can see, Minsky saying that you can't even solve the exclusive or problem, and it turns out that yeah, you absolutely can, and Minsky probably knew it, and he was smart enough to have known it. But he was doing it to protect, his suite of grants and his graduate students, right, and everybody else, right. So there were so deep sociological factors behind that paper, not just scientific factors, right. So that's the kind of thing. That's the kind of thing philosophers are good at, and it's their job to dig that stuff up, right. Scientists need to do science, and philosophers need to check them when they do nasty things.
So I want to go to 1990s now. So I was at a pharmaceutical company, John, in the 90s, and we put together what was then called machine learning based, sort of predictions of a pharmaceutical R&D program success and resourcing and things like that. Now, there is a large confusion in the term machine learning. So I want to get your your take on this. So machine learning appears to be a collection of statistical methods that existed a long time, including regressions. Regression is never a machine learning technique. It's beautiful.
Right.
And so, I sometimes think of this machine learning as known mathematical concepts that is given it's an old wine in a new bottle type thing. And then we have deep learning, which, as you say, the neural nets has been with us from the 1960s.
Right.
But higher computing power, higher levels of memory, GPUs, and so on, have given us a different view to deep learning, right? So that's sort of separating itself, I would say, from the general machine learning concepts.
That's right. Yeah. So I think that's really important to highlight, is that there's an interesting kind of complex history, and you're right, at its core, just statistics, and but what makes what makes machine learning interesting is machine learning gives a machine the ability to be flexible. So these systems degrade more gracefully. It's not like a rules-based system where it'll epically fail. Machine learning can fail and then rework itself, right? Use statistical analysis to reconstruct its network, right? I'll try it again. I'll try it again, and so it gives a much more natural feeling to how you and I might solve a problem, right? We might try something like trial and error, and a machine learning basically does that. So we sense a kinship there with the way our brains work and the way machine learning works, and that's the way it should be, because a lot of machine learning techniques are designed around what we understand about biological neurons. So they're artificial neural networks, and they attempt to mimic natural neural networks. They do it in a very different way, but they try to mimic it, and to some extent, they're successful at that. Now, so that's great, right? We've solved AI. The problem is that when we move into the deep learning, which is the world we kind of inhabit right now, the recent massive success of AI applications, right? The moving AI back into the public's eye. It's everywhere. We have AI applications all around us: smart speakers, autonomous cars, everything that happens on social networking, all the ads and stuff that predict your behavior. All of this is deep learning methods. And what is really interesting, what is different now than it was in the 90s and the early 2000s, is the amount of data that we have. So I mentioned earlier the Psych project. So that's Psych project was a really audacious project. He was hiring graduate students to basically type in facts, right? So the idea was to just give the machine more facts to deal with, right? The data, it needs data. AI is hungry for data. So let's give it data. but that turned out to be just this massively a problem that just cannot be accomplished. You just can't get
Unwieldy.
yeah, it's ungainly. Thank you. That's exactly the right word. So it was probably the right idea. It was just the implementation of it was really difficult, really costly. When we get to after the internet revolution, suddenly we have almost everyone on the planet willing to type data in, provide data for AI to work with, and we don't pay them a dime.
And Google made it very, very easy.
And Google made it extremely easy, right? So now this thing that was absolutely impossible before has become totally possible, because now floods of data every second are piling into these servers, and this gives AI everything it needs to work on, right? So now it's using these that's what deep learning is it's just unbelievably large databases of material that the machine can learn off of. So this is kind of an interesting thing. Um, if we're going to put have a maze, right, and we put a rat in that maze, and pretty soon, like within 1 or 2 shots, the rat learns the maze and knows how to get through it, as long as we're not changing the maze to get to the food, right? It's pretty quick. If we do that with a neural network, all right, it needs hundreds and hundreds of iterations to try to learn the maze. Once it does, then it behaves very similar to the rat. But what I'm trying to say is natural neural networks seem to have a more fine-tuned learning algorithm than what we've been able to come up with our artificial neural networks, even our deep learning neural networks. So they need thousands of tries, millions of tries, billions of tries before they start to get things right. But luckily, they're really fast. They move. They can iterate through these trials so much faster than you or I or a rat could do. So they don't. So in some ways, they don't. Do they need the capacities that a natural neural network has? Maybe they don't. Maybe they can just brute force their way into solving these problems that we would like our neural networks to solve.
So I want to ask you a philosophical question, John.
Mm-hmm.
I don't have the answer to this, but so I've been arguing for about 10 years now that the real problem in big data and artificial intelligence is how to discard data,
Mm-hmm.
not to use data.
Right.
So as people say, the more data you have, the better you're going to be. Not necessarily. We have no evidence for more data getting
Mm-hmm.
to better decisions.
Right.
So the brain appears to be very highly tuned to discard data, very efficiently discard data.
Exactly.
And I don't think we have focused on that in artificial intelligence. We are about using as much data as possible. So,
Yeah.
so what's your perspective on that?
So thanks for bringing that up, Gil. That's very, very astute of you. That is, to my mind, the exact problem, right? So a natural mind, most of them anyway, not all of them, but most of them have a capacity for judgment, and this can be taxed, right? As we've seen in our culture now, it's like difficult for some of us to dispose of junk data. So I wouldn't want to say we're perfect at it, but I do want to say that we have a capacity that our current machines don't have, and that is a capacity kind of to understand which data is more valuable, and we have to be, because we're not like our machines, right? We don't have access to all of human knowledge, right? We have to be very circumspect with the little bit of knowledge that we have, and we have to make sure that we're using quality knowledge. We also die, right? Our machines don't have a sense of life and death. So if we know when we make a fatal error, it's all over, right? So we're highly motivated to make sure to assess and deeply consider the data that we're using in our lives. So with that in mind, you're right. That is the problem. The best deep learning systems right now have no capacity to judge the data that they're fed. This is why we have algorithmic bias, right? Which is so this is why, like, we're getting sort of towards the end of our book, and that is these new wars, right? Which is now we found a system that kind of can brute force through a lot of these problems and get results, but can we trust those results, right? This is the really important problem. When we set a deep learning algorithm, find me all the best people to give mortgages to, and it chunks away at mountains and mountains of data, and it says, yeah, here's the people, right? These are your best risks. These are more risky, and these are people that I don't recommend you give mortgages to. Okay, great, right? Who's going to argue with that? Let's just give those people mortgages and let's start making money. But when you look at the results of that data, as we've been able to show time and time again now, the data that went into this, it works. It's more complicated than this, but for the listeners, this will make sense to them. So if we look back at least like the recent history of America in the last 100 years or so. So let's say I want to put all the successful and unsuccessful mortgages that happened in the last 100 years into my machine, and then it can then look for the qualifications that make one mortgage likely to succeed and another one likely to fail. Well, it's going to turn out that for instance, Black Americans weren't allowed into that market for sociological reasons, and even if they were allowed in that market, there were other sociological reasons which caused them to be in less valuable neighborhoods, in social situations where they were more likely to lose their job, fail at the mortgage. Okay, so the machine doesn't have any judgment about that. The machine doesn't know if that was right or wrong. It just looks at the results, right? Just give me the facts, and the facts are that if you look over the last 100 years, generally speaking, white clients are more likely to succeed at mortgages than anybody else. So the machine is all it's looking for. You just said, give me the clients that are most likely to succeed, and it's going to say, here's your list, right? And that list is going to be lily white, right?
Yeah, I have another example for you, John. There was an insurance company in New York deployed an AI machine that predicted that African Americans require less medical care. And it's based on historical data that
because they didn't get medical care, right? Yeah, right.
Less medical.
Yeah. So and that's like idiotic, right? These are idiotic, dangerous, and hurtful outcomes, right? That if we are not circumspect about them, we're going to cause massive damage with these brilliant whiz kid tools that we've developed, right?
So one thing you said is it's quite interesting for me philosophically, John. I don't know philosophy, but the idea that the brain is sort of a risk management system. It's not a pure computer. So when we started 300,000 years ago in African savanna, the objective function was not to be eaten by tigers and lions. And so we have sort of a tail risk management process, right? So we don't really optimize information. We just reduce the tail risk. And that's a different machine. We haven't really created those machines in silicon, right? So this idea that brains are similar to silicon-based machines is faulty, because the brains are trying to do something completely different. We're just trying to live. We don't want to be eaten.
That's right. Yeah, that's right. I won't use his name because he may not like this quote. But when I was a graduate student, I was talking to a very famous roboticist who the listeners would know, and one of the things in my school, we had this small little cognitive science program in Binghamton University. It's gone now, but at the time, We were interested in the holes in, like, we were always like trying to poke at the holes of all of this stuff that was going on. And so so one of the things that I really was excited by and in graduate school that was going on at the time was this embodied robotics, right? The robotics that didn't try to have a bunch of rules listed in it like they were doing at Stanford, but instead gave the machine neural networks so that it could, like, every time you turned it on, it relearned how to walk, right? So so it wasn't told how to walk, it was told how to learn to walk, and it could do that really quickly, right? So it'd stumble around, and then it'd be super skilled at that task within seconds. So okay, so that's really interesting, right? I'm really fascinated by this. So I go talk to one of the big names in that, and I'm really excited by this. And that person had switched to a different system that wasn't just modeling like cockroaches and biological creatures. They had switched to working on a human-like creature. And so I asked, like, I said, well, wait, you're the one that came up with this philosophical standpoint that we can't start at the top with machines, right? We have to evolve them up. Maybe we'll get to something like humans, but first we got to go through the cockroach and the rat stage, right? So so what's up? And he said, well, look, I'm getting older, and I don't want to be remembered as the guy who invented the robot cat. And and I thought, well, wait a minute, like you have given up, right? I felt so deflated and abandoned, because for me, if you could make something that was like a robot cat, right, that could jump up on things and navigate the world the way a cat does and survive, right, on its own in an alley, right, and thrive out on the savannah, right? What an amazing achievement, right? Because the robots that we have can't make it, more than 20 minutes from being charged, right? So like so what I'm trying to say is I agree with you, Gill, that biological creatures are incredibly fantastic, right? Even a cockroach is incredibly fantastic.
Oh,
yeah. And that our machines really pale in comparison. They do certain things through brute force, and they do it they present us with some astonishing capabilities, but they have not the one iota of the ability that they need to survive on their own, or even know what they're doing, or even know that they're in the earth, right?
they're
DeepMind
unlikely to invent quantum mechanics. Let's put it that way.
Right. Yeah, that's right. Exactly. Exactly. So so they're so disinterested and disassociated from the planet that they're on. And to me, that just feels like it's gone so far beyond what the initial, like, Turing and those people wanted from these machines. They wanted something that was right here, right now, you could have a conversation with. Try having a conversation with Siri. You can ask Siri questions. Siri can sometimes answer those questions, but there is no possible way you're going to have a conversation like we've had for an hour or so with Siri.
So I want to touch on your book, John. So the book was out last year, was it?
Yes. Mm-hmm.
So Great Philosophical Objections to Artificial Intelligence. We talked a little bit about the history of artificial intelligence, and I want to get into the sort of the philosophical aspects that you talk about here.
Mm-hmm.
So you say here arguments into 4 core topics. Is AI possible?
Mm-hmm.
Architectures of the mind, mental semantics and mental symbols, and rationality and creativity. You said this book shows the debate that played out between the philosophers on both sides of the question, and as well as the debate between philosophers and AI scientists and engineers building AI systems. Up to date and forward looking, the book is packed with fresh insights and supporting materials. So we talked a bit about the clash between computer scientists and engineers against philosophers.
Mm-hmm.
The problem with computer scientists and engineers, I'm one of them, is that they are too focused on the problem at hand,
Mm-hmm.
and they're less aware of sort of the larger questions. So as you say, the philosophers need to check their work
Right. Mm-hmm.
in some way because they get stuck very often,
Right.
I would say.
Yes.
And we have gotten stuck in this AI journey last 60 years, many
Mm-hmm.
times.
Mm-hmm.
So where are we today in 2022 from your perspective? Is philosophers trying to untangle the engineers from from the
Mm-hmm.
mess that they have made, or where
Yeah.
are
Yeah. So it's there's some interesting new developments. I think the biggest new development is that when I started this, my journey into the philosophy of AI a number of decades ago, uh, there were a small handful of people doing it. Uh, Today, because of the tremendous, like back then we were talking about, well, if AI succeeds, it's going to have these consequences, right? We don't have to do that anymore, right? AI has succeeded in a number of ways, and we can say these are the consequences, right? So if you would have listened to the community, 30 years ago, maybe we wouldn't have the algorithmic bias that we wouldn't have the actual damage done by actual algorithmic bias that we see today. But now that we have it, right, now we can say, look, we're not just talking science fiction. This is real, and this is just a precursor of the deeper problems that will happen as this technology goes forward in its inability to have the capacity to make judgments. So that has brought out the topic of AI ethics. So there's two branches of AI ethics. There's ethics in how AI is done, um, you know, uh, just watching for the abuses of algorithmic bias, right, and trying to fix it as it happens. That's one style of AI ethics, and the other style of AI ethics is how do we build a machine that can make its own judgment, right, as it's digging through the data, right? Could we build a machine that would say, wow, when I'm trying to solve the problem you asked me to solve, I'm getting this unfortunate social outcome, right? I'm getting all white applicants. Maybe I should look deeper into this problem, right? What's causing that, right? Why are my results so skewed, right? So the machine itself, could we build a machine such that it had its own capacity to judgment like that? So this is what I call artificial phronesis, right? So any good mortgage officer, right, if they were doing it all by hand and they started getting those results, they could have the capacity to judge, well, that's not really the society that I want to live in. Let me see what's behind the problem. Like, how do I change my problem so that I'm not getting these results? Can I reset my problem so that I get a more equitable result? So I want to see AI get to that level, to get to the level where it can have judgment. Artificial phronesis means a machine with artificial practical wisdom. Phronesis is just a Greek word that stands for, in English, we would call it practical wisdom, the ability to make wise choices, right?
Yeah, so it's sort of interesting, John. So um, what AI tells us that is that humans are not very different. We all hold our own biases.
Oh, yeah.
It's just sort of a historical analysis of data.
Hmm.
And, in the country that we live in today, half the country is willing to vote for a guy who is apparently
Yes.
very racist. Uh, and so heuristics that we form from accumulated historical information is
Hmm.
what we use in making decisions, and machines are not tremendously different from it. So what that tells me is that the brain is not really special.
Hmm.
It's just sort of a computer, isn't it?
Well, okay. So I want to push back a little bit on that. For the most part, I agree with you, of course. Like, who can not agree that there's been some massive problems? But I want to look at what are the causes of those massive problems. It is true humans can do a really poor job at ethical judgment. No question. Humans can also do really well at ethical judgment. You can just look at a Martin Luther King or a Gandhi, right? We can be creative. What I'm trying to say is we can be creative in ethics just the way an artist can be creative with paint. So it's a medium upon which we can be creative and create better worlds worth living, like my colleague Shannon Valor says. So futures worth living. So yes, we make mistakes. We are not doomed to make mistakes. So next I want to ask, and better than that, right? We're also capable of doing really amazing things. We've changed our cultures. Like, we're not locked into cultures. Slavery was easily justifiable through many cultures for many millennia. It's difficult to justify now. In fact, it's impossible to justify. It's not that it doesn't happen, but even the people doing it know they can't justify it, right? So I consider that a progress, right? Let's mark that on the win category for humans. So read, like, Steven Pinker, right? If you look at the data seems to show humans becoming more civilized pretty rapidly since World War II. So not that
a war going on, John.
But there's not. It's not a world war yet, right? So it's a little different than World War II. It's lesser. It's a lesser extent, right? It's hard. Like, I was just giving this lecture yesterday on Pinker in my classroom, and this is a difficult moment to be trying to back Pinker, but it's true. Like, the statistics show, even with the terrible things that happen in our world, there are far less of those terrible things than there were even in our recent past of just a few hundred years ago. So something has changed, right? Now I'm with you on this. We could change back. We can regress as fast as we progress, right? So that's really important. One of the reasons why I think we are currently regressing, even if you look at Pinker's data, you'll see it goes down, 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 and then somewhere around 2002 or 3, right? There's a little blip back up, right? So we didn't follow the trend all the way down. We bounced, right? And is that bounce going to shoot up into, like, we start a world nuclear war, right? Everything's off, right? That's the end of us, and we've proven that humans are one of the most worthless things nature has ever created. So that's a possible future, I grant it. But I don't want to live it. That's not the future I want to live. And the future that I want to live in, it exists, and we can get there. And we have the tools to get there, and we have to be smarter about what we're doing. And one of the main tools that's preventing us from getting to this world is the fact that we use dumb, non-judgmental AI to feed us our news. And that's how we get the politics that we saw in America the last 4 years, even continuing to today, right? We have a brain that is capable of judgment, but we also, it's not a perfect brain. It's not a super powerful brain, and it can be hijacked very easily by nefarious AI algorithms that feed you your news, right? So this is our main problem. This is a problem that's as bad as nuclear war, right? Because it could lead to nuclear war. We have to solve this problem. We have to put a lot of effort into it. Currently, we're doing just the worst job at it. Everybody I talk to in Silicon Valley, they all know this is a problem, but they all make their paycheck off of creating this problem. So they have no motivation to stop it. The government is too clueless to know what the problem is or how it even gets here. And in fact, they benefit from it, right? Certain members of the government absolutely benefit. There's people in Congress right now that would not be in Congress right now were it not for these algorithms that help get them there, right?
Yeah, I mean, it's a runaway train. So I want to get to another paper that you have, another very interesting paper, the role of consciousness and artificial phronēsis in AI ethical reasoning. Phronēsis, you say, is a philosophical term, and I don't know if I'm pronouncing that correctly, John, that refers to conscious ethical reasoning or practical wisdom. You say it's argued that in most adult humans, This capacity plays a primary role in high-level ethical reasoning. If you want AI systems to have the capacity to reason on ethical problems in a way that is functionally equivalent to competent humans, then we will need to create machines that display phronēsis or practical wisdom in their interactions with the human agents. Yeah, I mean, this is very intuitive on the surface. It's basically making a distinction between humans and machines in some ways, at least humans and contemporary AI machines, let's say.
Mm-hmm.
I often find not that much distinction.
Mm-hmm.
So let's get your take on this.
Okay, so what I'm driving at with that idea is I'm I'm setting up an empirical question. I don't have I'm unlike a lot of philosophers. A lot of philosophers sort of have this a priori, like they know the answer they want you to get to right before they start writing the paper. I'm not that way. So what I'm trying to do is set up a problem, right? I see this as a deep problem. We've created AI. Deep learning has been super effective, as we've talked about in the early parts of this interview, and it is now deployed and acting in the environment. So it's making decisions that affect your life. So it's impacting you ethically. In the philosophical community, we call these ethical impact agents. So these are autonomous agents that make decisions that have ethical value and impact, either good or bad, right? So so now what we just were talking about in the last 10 minutes or so is the problem where a machine can have an ethical impact but has no capacity to judge whether that impact was just or not, right? It does the impact. It's like a car hitting you, right? It's a mechanical process. The or train crash, right? It's just a mechanical process. So what we need to move from is ethical impact agents, which we already have, to I noticed two more levels, right? So the first level being what I would call artificial ethical agents, and then the last level being artificial moral agents. So what's the distinction there? An artificial ethical agent uses some includes in the data that it's taking in to decide on a situation. It also includes ethical propositions.
It's almost
ethical
rules-based,
outcomes.
isn't it?
What's that?
It's almost rules-based.
Right. That's right. And so so just expanding the amount and kinds of data. So this is not a trivial problem, because now you have to come up with the appropriate computer languages, the appropriate ways to model ethical outcomes, inputs and outcomes. That's a problem. It's a big problem, but I think it's a solvable problem, and it's one that we should be, there should be a branch of computer science that does it. There should be some there, and I know there are at least a few graduate students working on problems like this. So I just want to see more of that, and I want to see it get to the level where it starts to be implemented in AI programs that are actually out there that the public is interacting with. So that's where we are. That's probably the next 20 to 30 years is going to be making that jump, it's what we call machine ethics. It's mechanizing as much as possible, as much of it's like an expert system for ethics, right? However we want to solve that with whatever tools we currently have, but that's basically the idea. You at least have a module within the AI system that addresses ethical concerns, and then when the Waymo car, like we saw recently in San Francisco, where it drove away, right? And the police officers dealing with that Waymo car couldn't make sense of that, right? There was no way they can't communicate with that car. They can't. They're it's just doing what it does, right, on the streets of San Francisco. The engineers said, oh, well, this was perfectly reasonable, right, because it didn't feel safe where it was, and it moved over up the street to get to a point where it could be safe, right? So a human driver would have told the officer, look, I don't feel safe here. I want to just move right up over there, right? I'm not resisting arrest. I just would like to move over to that parking space. Can we do that, right? Yes or no? But right now, the machine just makes that choice, right, without the human interaction. So an artificial ethical agent would be able to have that communication, express its motivations, and discuss with its human operators, is that an ethical outcome? Is that a legal outcome? Should we do this or shouldn't we?
I quite like this distinction between ethics and morality, John. So ethics for me is sort of heuristics driven, rules driven.
Yeah.
We have, U.S. accounting generally accepted principles,
right.
U.S. GAAP.
Right.
There's, millions of rules in them.
Yep.
And we have millions of lawyers trying to get around them.
Right. Exactly. Yep.
The European GAAP is a little bit simpler. It's more don't do anything bad type gap.
Right.
It's very difficult to get around that. So there is a distinction between ethics and morality.
Yes.
And in the AI context, we can clearly create ethical AI agents, but they are very rigid in the formulation because they're going to be ethical given, because suppose I program it, as you say, just get white applicants in, that would be ethical and optimal from an AI perspective, right?
That's right.
So the morality question is the true AI question. And that part, I don't think we are anywhere close to solving, are we?
No, not even. No, it's hard to even think of how we would get there. The only reason why I think it's possible is because some human agents get there. So I know that I know that it exists somewhere in the space of possibilities, right? So so the exact path, right, that we move a machine up to get there, that's very far away. So that's this last level, this thing that I call artificial moral agent. And an artificial moral agent would have frenetic capacities that equal or exceed humans, right? We could imagine, like you said, humans are flawed, right? We could imagine a artificial moral agent that was way better than we are at these. Why wouldn't it be, right? We do a lot of, like as you correctly say, a lot of heuristics. We guess, we don't have it right. We come out of the womb not knowing anything, and we have to kind of hit or miss our way through life. Some of us get lucky and become very ethical agents. Many of us don't. So we don't want that for our machines, but we don't have to, because machines have the capacity that we don't, which is they don't come into the world as a blank slate. Right? We can find the programs that work, and the next machine just already has those programs. So it seems like we could evolve agents that would be better at these decisions than we are. Currently, they're not. They're way worse, right? I want to make that clear. The best we can do is these artificial ethical agents, which, as you say, have rules rigidity problems, and they will be little lawyers, right? And that is not law and ethics should coincide, but it often doesn't, right? It's often two separate things.
Yeah, I'm biased about this, John. I will today opt for 100 robotic senators in Washington,
right?
Than 100 humans.
Right. Yeah. Even the ones, even 100 deep minds, right, would do better than the current crop we have. Unfortunately, I think I might have to agree with you on that.
So I want to touch on I want to finish up with one of the older papers, Robots, Love, and Sex: The Ethics of Building a Love Machine. You say this paper will explore the ethical impacts of the use of effective computing by engineers and roboticists who program their machines to mimic and manipulate human emotions in order to evoke loving or amorous reactions from their human users.
Right.
We will see that it does seem plausible. You say that some people might buy a love machine if it were created, but it's argued here that principles from machine ethics have a role to play in the design of these machines. What do you
Mhm.
mean by machine ethics here?
Okay, so here's the uh, when I was researching this paper, I had to do a lot of research into the psychology and sociology of sex and love. And it turns out when you look at the people, when you read the people who have studied this like their whole careers, it turns out that there's at least 3 dozen reasons why somebody might choose to engage in a sexual relationship with somebody else, and some of those are just nasty, like uh, self-loathing, right? Some people will have
Hmm.
sex with another person because they hate themselves, right? So there's this ugly kind of dark side of sex, and then there's you do it because you're mutual attraction, like all the things that we want, that we write in the Hallmark cards, right? That's one level, and then there's all this stuff in between, and the really ugly dark stuff down at the bottom. So um so can we find a machine that people will have sex with? Absolutely, right? If you are self-loathing enough, right, you probably have sex with a dishwasher, right? So that's not a problem, right? We can absolutely, and we already do, build machines that people are perfectly willing to use to sexually gratify themselves. So that's not the problem. What I'm interested in that paper is, can we climb up that list, right, to these
Hmm.
more ethical, more uh, more healthy. Maybe do I want to say healthy? I think I do. And certainly ones that expand our horizons and our ability to be a better human, right? So, is there a way to build a machine that you would fall in love with and have sexual relations with, that would then make you a better person, right? No, we don't have a machine like that. Can we imagine one? Yes. Watch the movie Her, right? That's a movie where an AI helps the human character really grow as a person, right?
Hmm.
By the end of the movie, he's very different, and even though
The
the
problem is
relationship
it's
doesn't work out, few human relationships don't work out either. But they can also, even the ones that don't work out, can be really important to you and have really changed you and made you a better person, right? So that's what I'm interested in. Can we get out of you know the the lower grimy area, which we already exist, right? Yeah, you can buy those machines right now on the internet. They're a few $1,000s, right? Are they going to make you a better person? Arguably not. And can we get to the level where these machines where our relationships with these machines are just and useful and pro-social, right? That's hard to imagine, right? I think most people's imagination right now would be, wow, what a nightmare of android sex slaves. That seems like it's part of every dystopian science fiction, right? They exist within that. Um, I agree. That's where we can go. If we want to build that future, we can build that future. That one's in our sights. We know how to do it. Um, I'm arguing in this paper that we should look at this other potential future, which is a better potential future, which is one where, of course, those machines are again going to require some sort of artificial phronesis to be adequate companions and lovers for humans, and seek to make us better. Um, Machines can nudge us clearly. They can nudge us in unethical directions, which they do already. They could nudge us into more ethical directions as well, which they don't do, and which I'm arguing they should do.
Hmm. Yeah, I mean, I'm clearly biased about this, John. So I look at machines and I see them superior to macro problems, like we
Hmm.
discussed. I would love to put 100 robots in the Senate, Washington, D.C. today, and
Yeah.
I get better outcomes. I'm confident I'll get better outcomes.
Right.
So they are very good sort of macro problem solvers because they are, sort of much better to understand the context than humans, it appears. On the micro level, do humans really need machines for love and sex? I'm not exactly sure because we got 8 billion samples running around the small planet that we have.
Right. Right.
So if you can find somebody, go look somewhere else.
Yeah.
You don't need a machine, I would argue, at the micro level.
Yeah. So
was
what problems does it solve, and what problems do they create? You're right. It can create a lot of really bad problems. A colleague of mine, Kathleen Richards, considers something like sex robots to be one of the most dangerous things that could happen to women on the planet, because she feels that that basically it's a bunch of male engineers trying to create their Pygmalion fantasies into a machine and then dismiss all the actual women on the planet, right? So so yes, I can see that as a possibility. We have to be careful about that, and that it might be the motivation currently for the people who are currently working on these these technologies, because there are, it's not a gigantic community, but there are at least 3 or 4 different companies that are working on solving this problem. So yes, that could be a problem, and the other problem is that we've already seen this in social media where you have your filter bubble of information. Now you could have a machine that would be a social bubble, right? So now it's just you and the machine. The machine takes care of everything you would ever want because you're a terrible person from any other people, right? So it turns you into this little ugly troglodyte, right? That can live isolated socially and informationally, right? So so yeah, we might create a world like that. That would be just awful as well. My feeling is these technologies are going to come onto the market because people want them. Ever since the myth of Pygmalion, humans have wanted a machine like this. So so we are going to build one, right? And we already have, and we're just going to make bigger and better ones. So that cat's out of the bag. We have to now find ways to make them less of a social disaster, right? Social and personal disaster. Because you're right, currently computers are terrible at interpersonal relationships. We've spoken a whole hour about that already. And then I've just put on the table a potential solution to that. It's theoretical. It's not implementable right now. I am working a little bit with robotics lab in Palermo, and we are doing some experiments. We just started in the last year on looking at artificial phronesis. Not like I still don't think a machine is capable of doing it all in its own head. But I right now I'm exploring the idea that maybe human machine teams would do better. So what, like you said, could we should we replace the senators with machines? Should we keep machines out? My argument would be let's do both, right? Let's have senators with artificial prosthetics that allow them to think better and more clearly and more effectively about these gigantic problems that really are beyond the capacity of a unaided human brain to solve.
That's truly a dream, John. Make the senators think better. So I want to conclude. So I just want to ask you sort of a futuristic question. So, I mean, you've done a lot of work in this area, both from a philosophical perspective, from a scientific perspective. Where do you think we will be in, say, 10, 15 years from now? On 2 dimensions. One is sort of the congruence of humans and machines. Are we sort of coming together? And the Turing question, can be really sort of differentiate between them.
Mm-hmm.
So are we coming together?
Mm-hmm.
Is sort of the first question. The second question is, a lot of things you talked about here in terms of ethics and morality. If we are coming together, let's say, um, on sort of cosmetic basis, right? I ask a machine a question, I can figure out if machine is X or human is Y.
Mm-hmm.
But that's a mechanistic question,
Yeah.
right? There is a more advanced question in terms of what the machine thinks question.
Right.
So I don't know where we will be, but 10, 15 horizon, the first question is, are we coming together?
Mm-hmm.
And the larger horizon question is, if we were to come together, would the machines become moral in the long
Mm-hmm.
run?
Right. Right. So I think there currently that you put your finger on one of the current, as we say in the book, these wars, right? These places where there are divergent opinions. There isn't a consensus on this in the community of people that research and build and construct AI and sell AI applications. Um, there is one camp that seems to be pushing in the direction of the machine should do it for us, right? We should build machines such that they are capable of running the planet, and we become obsolete and retire, maybe even go into extinction, right? And then as this becomes a machine planet, like the interstellar a civilization that will come from Earth will not look like you and me, right? It's going to look like a machine, right, of some sort, because they would be able to actually achieve that in ways that you and I clearly can't, because we need this planet to survive. So it's going to be hard for us to leave it. So so that's one branch, right? The one branch, which is the AI branch, that is seeking to supplant and exceed and replace humanity. Then there's this other branch which you were discussing, which is often called intelligence augmentation. So can we use this technology not to replace us, but to make us better, right? Is there some way we can come together with machines so that we get an entity, like we've talked about? Machines are really great, super fast and accurate, but lack judgment. We have the capacity to make judgments, but we make lots of mistakes. We operate on minuscule amounts of data. We make heuristic jumps, and that's our problem, right? So obviously, right, it doesn't take a rocket scientist to figure this out. If you put these two capacities together, you now have an entity that is capable of judgment and capable of all the beautiful and philosophical and artistic things that we're capable of. Plus, it has greatly enhanced capacities to make that stuff happen: more data, more accuracy, more speed in its judgments. That seems like a good place to be, like a place where we should shoot for. In that case, thinking many centuries in the future, then maybe we are an intergalactic civilization that has the capacity to both survive out there and thrive right at the same time. So so yeah, I think that's the direction that we should think about. That's always been my like big grand plan. So so is there a way to humanize technology, right? That's been my whole life, has been spent in that direction. How do we humanize technology, bring the two together in such a way that we aren't working against each other, we are working in tandem and are capable of creating a much better, much more just, and much more livable world. Um, uh, the other direction I find really strangely almost psychotic, right? Why would I work really hard to like spend my whole life doing working 24/7 to make the human race disappear? But some people are motivated by that, and that's where they're going. So I see two. So where will we be in 10 years? Really depends on who's got the money, right? If these
Yeah.
guys got the money, we're in dystopia, right? If these guys get the money, which they currently aren't, then we're in a much better place.
Yeah, I mean, I don't want to belabor on this. So, John, so I see an explosion outside the Earth into, as you say, interstellar travel and accommodation. There's sort of an implosion inside the human brain of similar magnitude, I would argue, which is the human brain appears to be getting more confused.
Yes.
In some ways, So AI is sort of a confusing phenomenon,
right,
for the human brain. And if so, what are the implications?
Oh yeah, you're right. As we were discussing earlier, natural brains are finely tuned for a specific job, and that specific job didn't include, the world that we currently live in. Obviously, it was possible, right? It was possible for those brains to get us here, and they did. But the question is, have we hit some kind of a limit, right? Some computational cognitive limit where now our brains are not helping us move forward; they're actually getting in our way. And I think there's some good evidence to that. It's probably why we see, massive amounts of depression and bad mental health in our societies, bad physical and mental health in our society. The society that we've created, clearly not healthy for us on multiple dimensions. So you're right. We can't just continue on ahead, and we can't assume that things are just going to work themselves out, because they're not. Our choices then would be take a step back, right? Which is the kind of back to nature sort of thing. That has its own like ugly end, right? What are we going to do with the billions of extra people? Right, the planet won't support us in an old-fashioned lifestyle. So a lot of people are going to die in that direction. If we just charge ahead without thinking about it, a lot of people are going to die in that direction. This is why I'm spending a lot of time arguing for this other possible dimension, which is we start really thinking about how to create healthy technologies that help us enhance our cognitive capacities and our ability to deal with the world that we've created, and deal with the possible worlds that we could create. Right now, we seem to have been hit a real brick wall, a wall that nefarious actors can take advantage of and have taken advantage of, and we are in deep trouble right now. I'm just trying to stay hopeful. I think there's a solution, right? And I think that solution doesn't involve the death of billions of people on the planet. I think we can actually continue to grow, and I'd like us to just do it smarter. Like the Elon Musk solution is, let's just go for it, right? Mars ho, right? And that's going to have a whole lot of human casualties in its wake, right? It's brute force. It's a difficult road to hoe, and I don't see like brains that were evolved for the African savanna sitting on Mars. Like what are they gonna do, right? I think they're gonna be depressed as hell, and it's just gonna be a lot of drugs and stuff to try to keep themselves from killing themselves. So yeah, that's an ugly future. Let's not go there. Let's instead devise technologies that kind of don't destroy our world and help us maintain it and make it super livable for everybody who's here, and find ways to change our biology and our cognitive architecture, so that some of us could go off into interstellar space and live happily out there. There's ways to do this, right? We just have to be smart and circumspect about how we do it.
Yeah, let's hope Elon gets distracted by Twitter.
Exactly, right.
There is no subsidies there,
No,
so that might be a little different.
Yep.
But
right.
hopefully we'll get better. Excellent, John.
Yeah,
This has been great. Thanks so much for spending time with me.
Yeah, you're welcome. You're welcome.
Thank you.